Good afternoon, friends and dear students. It gives me immense pleasure to be here again for my course, Flight Mechanics. This Flight Mechanics course is related to the fourth semester of Aeronautical Engineering from Institute of Aeronautical Engineering, Hyderabad, India. As of now, I have covered all the 5 modules. In the first module, it was Introduction to Flight Mechanics. In that, basics of International Atmosphere, ISA, then different velocities, air speeds like equivalent airspeed, true airspeed, calibrated airspeed. Also, we have seen the lift, drag polar. Then we have approached to the module 2, which is the cruise flight. In cruise flight, we have done about thrust required, power required, thrust available, power available. We have find out the equation of motion for cruise flight. We have find out the stall speed, minimum drag speed, minimum endurance, range. Then we have gone to the module 3. In module 3, we have the climb performance. In the climb performance, we have find out the climb angle, maximum climb angle, rate of climb, different equations for different speeds, and so on. Next, we have in the fourth module, we have the maneuvering flight. In maneuvering flight, we have seen the turning flight, how to find the radius of the turn, then time to turn, bank angle. These things we have find out. Also, we have seen the vertical maneuvers like pull up, pull down, nose down, Venn diagram, load factor, maneuvering point, maneuvering velocity, stall limits, positive and the negative, structural limit, positive and the negative, and VNE, never exceed speed. This we have already done, we have calculated. In the module 5, we have done the about landing and takeoff performance, fuel planning, different types of fuels. These all things I have already covered. We have already done some 15 lectures on different numericals and problem solving. Now today my topic is definition and the terminology, which is for the climb and the descent performance of the aircraft. I am Dr. Yagya Dutta Dwivedi, professor from Institute of Aeronautical Engineering, Hyderabad, India. In today's topics, definition and the terminology of climb, range, rate of climb, sink rate, these all things we will be discussing. Definition and the terminology related to the climb performance. So define the climb. A climb is the operation of increasing the altitude of an aircraft. It is also the logical phase of a typical flight, the climb phase or the climb out, following takeoff and predicting the cruise. During the climb phase, there is an increase in altitude to a predetermined level. So if you see here, this is your takeoff. From here, it is the ground level. From here, aircraft has to increase the altitude. So this is your altitude from here to here. Altitude is increased. Altitude is increased. So this is called here the climb phase. In this climb phase, altitude is increased and it is a logical phase of a typical flight. The climb or the climb out following takeoff. So here is the takeoff and preceding the, and here we have the cruise. So the climb is between cruise and the takeoff. That area where the altitude is increasing, that is called the climb performance. During the climb phase, there is an increase in altitude to predetermined level. So some altitude is given. That altitude is achieved by the help of the climb performance. Descent is the another one. After the cruise, aircraft will start descending, and then it is, so this is the descent flight, and here is the landing. So a descent during air travel is any portion where an aircraft decreases altitude and is the opposite of an ascent or the climb. So it is opposite to the climb performance. And here if you see, aircraft is like this: climb, cruise, then after cruise, this is the descent flight, then this is the landing. So descent flight is in between cruise and in between the landing, and here it may be loiter also if required sometimes. So a descent during air travel is any portion where an aircraft decreases altitude. So here altitude is decreasing, so decrease in altitude. So from here to here, this is your descent. From this is the descent where altitude is decreased. So that is your descent performance. Now define pitch power table. So here angle of attack required for certain climb and descent rates are dependent on the variable such as gross weight, center of gravity location, and the indicated airspeed in relation to the produce a certain pitch altitude. So pitch power table, it is the table which is as per the angle of attack, how much power is required. So that is the requirement for this. Now we will go for the rate of climb, ROC. I means indicator. How to decide rate of climb? The higher you are, the better your fuel efficiency. So you will want to climb quickly and then stay at high as you can until you need to start your descent in order to land. So how much per unit time if your aircraft is climbing like this? So this is your velocity V, this is the gamma. So rate of climb is, this is the vertical velocity. So we can write V sine gamma, and this is the rate of climb, and this can be indicated in the cockpit by the instrument known as ROC indicator. Define climb and descent angle. The flight path angle, also referred to as the climb or the descent angle, is calculated as the vertical angle between the velocity vector, that is where the airplane is going and the earth horizon. So the flight path angle, also referred as a climb or the descent angle gamma, is calculated as the vertical angle between the velocity vector, that is where the airplane is going, and the earth horizon. So this is the climb angle. This angle from here to here. This angle from here, this is the horizontal horizon, and this is aircraft velocity vector. This angle is the gamma, and this gamma is called the climb angle, or the, if it is going down like this is gamma, and here is the aircraft. So this is the descent angle, and this is the climb angle. Define L by D ratio. This L by D ratio is also known as performance of the wing or airfoil. Efficiency, another way we can say that it is efficiency also. So L by D max results in the lowest energy required per distance traveled, and disregarding propulsion efficiency will give the most economical fuel consumption for a long range travel. This will also give the best glide distance in unpowered flight. So if we have L by D max, then we will get maximum range and endurance for unpowered flight or gliding flight. Define descent rate. Rate of descent is the vertical component of the aircraft velocity, normally expressed in feet per minute, factor affecting the descent rate. So if you see here, if your aircraft is descending from here, this is your earth, so it is descending like this. So this is the vertical, this. If this is the gamma, so this is the velocity v, so it will be v sine gamma negative, because it is coming down. So sine minus gamma is equal to minus sine gamma. So this is called the descent rate. So rate of climb, and this is the rate of descent. Rate of DES, descent of aircraft. Define the rule of three. So during the descent, aircraft follows some relation between the horizontal travel and the vertical travel. In aviation, the rule of three, or 3:1 rule of descent, is that 3 miles of travel should be allowed for every 1,000 feet or 300 meters. So if 3 miles of the travel should allow, so if aircraft is here and it is descending like this, so for every here 300 meter, your aircraft should fly horizontal distance 3 miles. So this is called 3:1 rule, or rule of three. Rule of three. Best rate of climb. The best rate of climb is predicted to be an airspeed greater than the minimum drag speed. So if I draw here velocity versus thrust, So like this. So here best rate of climb is predicted to be airspeed greater than the minimum drag speed. So this is the minimum drag speed. This is the drag minimum, and this speed is the V minimum drag. But best rate of climb, if we make here one tangent to this tangent is the best V maximum ROC. So it is greater than, so VM ROC is greater than VMD. Maybe 10 to 20% it is greater than the, so this is the best rate of climb, and minimum drag speed is different. If you want to fly for the best rate of climb, your speed should be VM ROC, and if you want that your drag should be minimum. For the maximum range, for max range, you have to fly at V minimum drag. For max climb, you have to fly V maximum rate of climb, max, and this V max ROC is greater than VMD. Define steepest gradient. How much aircraft can, this is the your aircraft, so how much maximum climb angle, gamma maximum, how much should be there, that is the requirement. So steepest gradient occurs when u is equal to 1. This is the definition of steepest gradient. Define minimum sink rate. Minimum sink rate is achieved by flying at minimum power speed of the aircraft. Flying at this speed will maximize the time of glide flight. So minimum sink rate means the rate of climb, the rate of descent is minimum. Rate of descent is minimum. That is called the minimum descent rate. Minimum sink rate is achieved by flying at a minimum power speed of the aircraft. Flying at this speed will maximize the time of glide flight. Define minimum fuel climb. The minimum fuel climb will occur at the airspeed for best rate of climb. The minimum fuel climb will occur at the airspeed for best rate of climb. So, if you are flying at best rate of climb, then fuel consumption of the aircraft will be minimum. So that is a requirement for the minimum fuel climb. Phases of the descent flight. In descent flight, we have the cruise flight, then TMA descent, that is approaching descent, and the final approach. So I am making here dotted, which is not the descent. First it is the takeoff, then we have the climb, Then we have the cruise. So from here onwards, your descent flight starts. From the cruise, then it will start slowly, it will fall down. That is called TMA, DES, descent. Then this is the runway here, and aircraft will start approaching the runway. This is the runway. This is called the approach, final, approach to land. So these are the three phases for the landing of the aircraft. It starts from here. Just before the cruise, it will start like this. And so I will just put here some other color. From here, this is another one. So this is the 1, this is the 2, and this is the 3. 3 phases are here. Then aircraft is landed here. So up to here, your aircraft is in descent. This is called the phases of descent flight. Define specific total energy. The combination of the potential and kinetic energies of aircraft per module mass is known as the specific total energy. The combination of the potential and kinetic energy of aircraft per module mass, per unit mass, the KE plus PE. So we know that kinetic energy half mv square plus mgh. This is called the total energy per unit mass divided by m. So this will be v square by 2 plus gh. This is the specific energy, total specific energy of the aircraft. Define energy height. The above is the sometimes called the energy height, and this is called the h. So this h, where the kinetic energy and the potential energy per unit mass, this height is called the energy height, since it represents the height the aircraft will attain at all its kinetic energy were to be converted to potential energy. So in this case, if you see this gh is equal to minus v square by 2, so h is equal to minus half v square by g. So this is called the energy height. Energy height. It depends upon this. If it is falling down, it will be minus. If it is going up, it will be the plus. Define minimum power to take off. As you know that during the takeoff, aircraft need some extra power. So how much power is required? A minimum power, how much is required for the taking of the aircraft? To conform to the airworthiness, a multi-engine aircraft needs to be able to climb with one engine inoperative in the takeoff configuration and exceeded a minimum climb gradient requirement. If suppose we have the 2 engine in a aircraft and one engine is failed, being one engine, this one engine should be able to provide the minimum power to climb during takeoff. So that is called the minimum power. Engine should be able to operate within one engine. Your aircraft should be fly. It should be able to take off from the ground. Define constant of climb performance. The safety parameters like stalling speed, minimum control speed, noise limitations, aircraft altitudes, change of cabin pressure, these all things are the constant of the performance of the aircraft. As you go high speed, stalling speed is the speed at which aircraft will not able to sustain in the air. That is the minimum speed of the aircraft. Minimum control speed, it is more than the stalling speed. Somewhere it is 1.3 into Vs. Then noise limitations are there. How much noise your engine is producing. Aircraft altitude, at what altitude your aircraft is flying. Change in the cabin pressure. Because as you go high altitude, the pressure outside is reduced. Inside pressure we have to maintain. So cabin pressurization is very important for any aircraft. This cabin pressurization, aircraft altitude, noise limitations, and minimum control speed, stalling speed, these are the few constraints of the aircraft performance on the aircraft. Now, another word is define excess power. And we have learned that excess power is T minus D, where TA is equal to, T is equal to thrust available, and it is a TA, and D is equal to thrust required. So the difference between TA minus TR is equal to, this is called excess thrust, or if we make multiply by the velocity, so it will be PA minus PR. This is called excess power. So the difference between the total available power, that is called PA, and the required power PR is called the excess power. For having a good climb, this difference should be maximum. So just I am drawing a plot for here like this. This is the velocity, this is the power, like this is the power required, and this is here power available. This is the power available. So here if you see, this is the difference between PA minus PR. This is called excess power. So PA minus PR. And as much you have this value, that much aircraft will able to climb. And this is the point where you have, this is the velocity for max climb. Because in this, you have the highest excess power. The effect of this altitude, as you go higher altitude and higher altitude, this plot will be like this, and PA will be falling down like this, like this. So one situation will come where you will not have excess power, and this is the speed, this is the V max. And as you go high and high, your density is reducing, your power required will be increasing, power available will be decreasing, and the excess power will be reducing. As you go to the service ceiling, your rate of climb will be 100 feet per minute. As you go above that, one point will come, there will not be a zero rate of climb will be experienced. That point is called the absolute ceiling. And where you have the 100 feet per minute, that height is called the service ceiling. So this service ceiling and the absolute ceiling are depend upon the how much power is available on the engine. If you have the very high power engine, then your absolute ceiling will be very high. Your aircraft can fly at a higher altitude. So during selection of the aircraft, we have to make sure that whatever the condition we have given, our aircraft should be able to meet that altitude. As you have the higher altitude aircraft, and so it is very safe, because if another aircraft cannot fly up to that, they cannot dogfight with that aircraft. So that is the intention for this service ceiling. It is very important parameter. Absolute ceiling also very important parameter for any aircraft performance. Now we will be discussing about types of climb and the descent. What are the types of climb? Here are generally 4 types of climb. That is the best angle climb. So first one is best angle climb, best rate climb, cruise climb, recommended. These are the, so best angle climb is your aircraft should able to climb from here to here at the best angle. This is the gamma max. And another one is this one, V sin gamma. If this V sin gamma is rate of climb is known as V sin gamma. So this best, we should have this best. So we can say that sin gamma is equal to h by x. So h is equal to x, when gamma is equal to 90 degree. Okay. So in this way we have to find out cruise climb and other things also. Types of descent. So if you see here, different types of forces are here in this diagram. Here is the drag, here is the opposite of the thrust. This is the relative velocity. Lift will act always in this perpendicular to this. Okay, so here this is the weight. This weight, this W1 is equal to cos of gamma. So lift will be equal to this, drag will be equal to the thrust. Types of descent. There are also generally 3 types of descent. One is the glide powered. Another is, so first one is the glide powered. Second one is the cruise. Glide, second one is the powered, third one is the cruise. It is recommended you teach the best rate of climb and the glide with demonstration of the other as permit. Now we will have some terms here. Emergency overrun. So I will be discussing these terms one by one. Emergency overrun. A surface before the takeoff area on the runway that is kept clear. This portion is designed to minimize the damage to an aircraft if it is unable to stop. So a surface that the takeoff area on the runway that is kept clear means if this is the runway here, aircraft is starting from here and it is taking off from here. This is the emergency overrun. Emergency overrun. In case of some engine is fail or something, aircraft can run here and your safety can be minimized. So surface before the takeoff area on the runway that is kept clear. This portion is designed to minimize damage to an aircraft if it is unable to stop. So if it is not able to stop, it can run here. Empennage. Empennage, a term of aircraft tail. So I will just draw here one aircraft. This is your wing. This is your tail. This is your rudder. Here is this area is called empennage. Behind area where your horizontal tail is there, your vertical tail is there, your rudder is there, elevators are there, and some part of the fuselage where these things are attached, they all are called the empennage. This is here we have the rudder. This is here elevator. This is the wing. a term for the aircraft tail, which is made up of a rudder, a fin and a stabilizer, that is also known as the tail or the tail assembly, and provides stability for the jet during flight. Engine. An aircraft engine is a machine that converts energy to power the plane. So these engines are used to locomote the aircraft or to propel the aircraft. Estimated time en route, commonly referred to as ETE, estimate time to en route. The estimated flight time to a journey will take from departure to arrival in the destination of the checkpoint. So from here to the here, from point A to B, how much time is needed? So it is estimated, and that is known as a ETE. Estimated time of arrival, ETA. Commonly referred as a ETA, that time an aircraft is predicted to arrive in its destination or the checkpoint. So from one point to the destination, how much time is required? Time. This time is called ETA. From departure to arrival to new destination. Now we will discuss about descent. Means just now we have seen that if this is the ground, your aircraft is here. It is starting like this. So this flight is called the descent. Descent flight. A flight maneuver that causes a downward inclination. So downward inclination, this is called the descent. Distress. A condition on the aircraft that signals danger and requires immediate action. Distress means in problem. Whenever you have some problem in aircraft, it may create injury, damage to the property. Even sometimes it may happen that some accident may take place and lot of death may occur. Aircraft may be in distress for number of reasons. Maybe some technical error, some human error, some calamities, natural calamities may happen. So a condition on the aircraft that signals danger and requires immediate action. Downwash. In aeronautics, the term describes air that is deflected downwards by the aircraft wing or a rotor blade on a helicopter, usually when the plane is taking off. So this downwash, if you see the airfoil like this, if flow is coming from this direction, it will go like this. So here, this is called here downwash. Downwash is happening due to the circulation over the wing, and air is entering down and your lift is generated. Like in helicopter, all the three blades, they are rotated by the help of the engine. And if it is rotated like this, air will be sucked from this side and air will be moving down. This is called the down wash. This downwash will give the lift of the aircraft or lift of the helicopter. Same way for the fixed wing also. This is the fixed wing. This is the rotary wing or helicopter. So like this downwash is done. Down wing leg. A flight path that turns parallel to the landing runway in the opposite direction of the landing. A flight path that turns parallel to the landing runway in the opposite direction of the landing. Roll. Motion on an aircraft along its nose to tail axis. So, roll is what? Motion on an aircraft along its nose to tail axis. So, if this is the aircraft, these are the wings, these are the tail, this is the axis, this is the nose, this is the tail. So, nose to tail, if your aircraft is moving like this, if this is the aircraft, this is called the rolling. Rolling of the aircraft, left, right or the left, right wing down or the left wing down, it is called the roll. Rudder. If you see here, this is the vertical tail and here we have the rudder. This is the rudder, a vertical control surface in the tail of an airplane. So it is vertical. This I am writing here, just I will color it. It is hinged two places. Okay, it hinged into two places and this is called the rudder. Rudder gives the yawing motion. If aircraft is flying and you move rudder like this, left, nose will go left. If you make right, nose will go to the right. As you move your rudder, in which direction, nose will go in the same direction. Runway, a rectangular area of the ground set aside for aircraft to land and the takeoff. So, like this one strip is there. In between we have the center line. There will be some yellow lines here and here. And this is called the runway, where aircraft is landing and the takeoff and doing all type of ground maneuvers. Short field, a short runway length at the airport that requires a pilot to take off or land at airport within the shortest possible distance. So a short field runway length at the airport that requires a pilot to take off or land an aircraft within the shortest possible distance. Single engine, an aircraft with just one engine. Single engine jet includes light aircraft such as Cessnas. Short field again, the same thing, an unpaved aircraft runway typically comprised of grass or the dirt. Short field again, if it is not the concrete, there we have some grassy, some mud, these all things are there. It is not the very much, this is called the short field. Squawk, a 4-digit number assigned to an aircraft. The pilot can use this number to identify his or her plane when contacting ATC. So a 4-digit number is provided to identify the aircraft. Next is straight flight. The flight maneuver that causes the aircraft to maintain the same direction. So if we are moving from north to south, maintaining the same distance, same direction, it is called the straight flight. It may be deviated due to some wind and some gust and all, but mostly it is maintained the straight flight. Tail, the aerodynamic surface located at the rear of the aircraft. So if this is your nose, this is your This area is called the tail. So the aerodynamic surfaces located at the rear of an aircraft. So these surfaces may be rudder, elevator. This is the horizontal tail. This is the vertical tail. This is the rudder. And this whole portion is called the tail. Threshold. The portion of the runway that is available for landing. So if I make here the runway like this, here we will make some yellow color line at the two ends. The portion of the runway that is available for the landing. So this is called the threshold. From here to here, it is pure area where we can land our aircraft. Throttle, it is a lever which is fitted inside the cockpit. If you move up and down, your RPM of the engine will increase. Throttle is a valve in the carburetor that controls the amount of fuel that can enter the engine. So throttle is like accelerator of the vehicle. Accelerator of the vehicle. What is the thrust? An aerodynamic force produced by a propeller or engine that pushed an aircraft forward. An aerodynamic force produced by a propeller or engine that pushes an aircraft forward. So if you make this aircraft, here is an engine, it is rotating a propeller, or it is maybe the jet. So this will make this aircraft to move like this. So this force is called the thrust, which will trying to move the aircraft forward. Torque, a force that aims to produce rotation. So the force which is trying to twist or the rotation, it is called the torque. Tower, a radio call sign used to reach the local controller. So a radio call sign, it is some call sign, some numbers are given, that is called the tower. In the next lecture, I will be discussing about definition and the terminology of the module 4, that is maneuvering performance. In that, we will be discussing about turn flight, pull-up flight, pull-down flight, VN diagram, different parameters, and so on. We have the references: Anderson J.D. Jr., Aircraft Performance and Design, International Edition, McGraw-Hill's, first edition, 1999. SL by ME, Aircraft Performance Theory and Practice, AIA Education Series, AIA 2. Any questions, you are welcome to ask to my email yddwivedi@gmail.com. Please do like and subscribe this my channel. Also write the comments in the comment box. Don't forget to click the bell icon. Thank you very much for the joining. We will be meeting for the next lecture. Till then, goodbye.
Like, share and subscribe. Hit the bell icon for more updates.